All right, great. Looks like you're the only one on board right now. A little bit surprising. I would have expected a few more people. Maybe throughout the hour, we'll have a couple more people come on. Of course, um, this event, I guess you guys had an event previously with the School of Engineering, and then we have these follow-up events for each of the individual departments where people get the opportunity to basically talk to the department heads. I think on Thursday we have or next Tuesday, I believe, it's going to be a discussion with the associate department head. He actually oversees the undergraduate program.
Okay.
So he would also have a lot of useful information too for the department. Um, I'm here basically mostly to answer questions. There was online, there is a PowerPoint. I'm not sure. Were you able to see that? Were you able to see?
I flipped through that.
Okay. So that basically outlines a little bit about the department. I can provide you a lot more details too as well. I could tell you just for starters a little bit about BME. So BME essentially it's sort of a highly interdisciplinary area, basically integrating biological sciences, medicine, and engineering. And then within engineering, it sort of encompasses all the different areas of engineering, depending exactly on which focus in biomedical engineering you're interested in. And essentially, the whole idea is to sort of basically use engineering as tools for developing technology and also coming up with new ways for studying biological systems, studying the human body, and developing things like clinical technologies like diagnostic tools, or even developing new therapies that could be used in the clinic. So it's a pretty broad field, and it essentially takes from all the biologicals and the physical sciences, and it sort of takes and integrates all of those. Now, it's highly broken up into different disciplines. You may have seen that there's a variety of different disciplines within BME.
Yes.
So on the one hand, we have biomechanics, which is sort of looking at interactions, physical interactions between the human body. It takes a lot from mechanical engineering and looking at the interactions with the human body, how forces affect. It could be looking at forces that are occurring, while you're moving, let's say when you're running or something like that. But it could also be forces that are being enacted on single cells, as an example.
Right.
So it's pretty broad. We have biomaterials, which is basically an area that covers how to build materials that are biologically compatible. And also that in that area, a little bit of tissue engineering, how to develop new tissues that could be used, for example, to build new organs, graft skin, so on and so on. We have bioinstrumentation as another area. That area essentially covers development of medical devices, new imaging tools that could be used to look at the human body more precisely. Um, Also, developing ways to diagnose disease or better treat it. Where, for example, EKG devices would be a very sort of traditional type of device that is commonly used in a clinic.
Right.
It just measures your cardiac rhythm, and from that you could actually come up with ways to diagnose, if you have some heart dysfunction or something like that. So in essence, it covers a number of different areas. And it's subdivided into these sub-disciplines, taking from all the engineering disciplines. So, either some of the areas are more focused on mechanical engineering, some more focused on electrical engineering, computer science, so on and so on. Others, material science, for example, as a whole. And just to give you again, just going back to the basic overview that was provided in the handout. Our department is pretty new. It was as a department we started, I believe it was 2012 or 2014. I can't recall right now, but it's somewhere around there. So as a department, it's pretty new. The undergrad program was actually developed back in 2000. And the graduate level program was actually enacted even before that, back in the late 60s. So it's been around for quite a while. But as a department, we are relatively new. The undergrad program is accredited by the accreditation board. It's called ABET. So that's the accreditation board that accredits all engineering programs in the United States. So we've been, I believe we've been continuously accredited since 2005. So at this point, the program is relatively established, and we have been growing. I mean, since we became a department, the faculty size has grown. We have roughly about 40, 45 faculty that are considered part of the core. These are the main contributors to the department. But we also have a number of faculty who are also what we call affiliated faculty. Those are faculty in other departments like biology, physiology department, some in the medical school, etc. Some of these faculty contribute to biomedical engineering in various ways, but they're not directly the main contributors of the program. So we do interact quite a bit throughout the university as a whole. So I guess that gives you, just a sort of broad, very general background, and I'd be more than glad to answer any questions that were either in the PDF that was distributed that you could get online, or if you just have your own individual questions, I'll be more than glad to answer those.
I was just curious about your nanotech program.
We have a number of faculty in it. The nanotech, there's no nanotechnology concentration per se. So concentrations, if we look it up, let me just see if I could show this to you. I'm going to try to share the video from my screen. So I believe that handout outlined the main concentrations.
Yes, biomaterials, tissue engineering concentration, biomechanics, and yeah, I have it right in front of me. So
yeah, so nanotechnology is not a concentration per se. So you wouldn't necessarily get a degree that says you have a concentration in nanotechnology. We do have a number of faculty that are using approaches from nanotechnology, and they're using those in their research. I think in some of the courses, there's courses on what's called micro-mechanical devices, MEMS, micro-electrical mechanical devices. Those are probably some of the areas that are closest associated to that. And I know there is some upper division courses that deal with some of those topics. There are courses also, I believe, in mechanical engineering that deal with some of the micro and nano type technology. So we don't have anything specific. So it's not like that you could get a concentration in that area per se, but there are courses throughout, a handful taught by our own faculty. I believe Cass Hoshino is one of them from our department who actually teaches some of that material. There's also, like I said, people in mechanical engineering. So throughout the university, there's a handful of people who do nano-type technology. And, at the upper division, once you get to your senior year, you're able to take, electives, which would allow you to take one or two courses in that area.
I was also curious about the 3D printing, just organic matter. I know that's in development.
Yeah, so there is, we do have some 3D printing. So we have a small facility, laboratory facility that's being used for 3D printing. There's actually a faculty at the health center. Her name is Lisa Kuhn. She's actually the associate head of the department at the health center because I didn't really describe this, but the department's actually between the Storrs campus, which is where, of course, all the undergrads are located, and as well as the healthcare campus, which is in Farmington. So she actually is the associate department head out there, and she's been teaching a course, which I think is pretty new. It might be like a year old or something like that. So she's been teaching a course on 3D printing that literally just focuses on that and applications of 3D printing. I think these are mostly for biomaterials and tissue type engineering applications from what I understand. That's not my expertise, but from what I understand, that's the kind of applications that they focus on in that course. So there is, without a doubt, there's some some work being done in that area. We have a small lab that actually uses 3D printing technology to do some of these things.
So just curious, like what kind of internship opportunities would there be for someone with biomedical engineering degree, or not a degree, but a major?
Yeah, we don't have a formal internship program that I know of. So I know students have been able to get internships. The School of Engineering, I think, may have some means of providing, basically when there are internships available to the School of Engineering, the undergraduate dean's office in School of Engineering, they may keep postings of some of the internships and stuff like that. So I know some students have been able to get them over the years, but it's just not a well-established program that I know of. So I'm not familiar with all the details. I think I would think the undergraduate dean's office would be, for School of Engineering, would be the person to contact. They might be able to provide more information. The name for that is Dan Berkey. So he's probably, when you had the main open house event, he's probably the person that spoke and that was the main speaker for that. That would have been, I think, last week. So you might want to reach out to them. They might know more about how to go about it. I'm not quite sure of all the procedures for doing that.
I mean, just one of my concerns is, finding, after graduating, just finding a job. So I know work experience is pretty important.
Yeah, I know. Like I said, I know some students have done it, and that's without a doubt a great way to, to basically get acquainted with the company, and then that opens up prospects for sure for getting a job, without a doubt. So that's definitely one of the benefits if you could do it. I just don't. Unfortunately, I don't know all the details of how it actually, how you get hooked up with an internship like that. And again, I think Dan Berkey's office would be the dean of School of Engineering, undergrads dean. So he would be definitely the person that probably would know, or that office would be the people who know about that for sure. Looks like we have somebody else here too. Logan, it looks like.
How you doing?
Hi, how you doing? I don't know. So if you have questions or anything, you're more than welcome to join in as well.
All right, I have one as of right now. What's
Sure.
the average student to facility ratio for the classrooms?
You're talking about the how many the students per faculty or per course, you're saying?
Yes. What's the average?
It varies quite a bit. It depends on the course that you're looking at. So I think once you get into some of the upper divisions, so just to give you an idea, the department right now, on a per year, each class has been hovering somewhere around 80 students or so. So we've been bringing in approximately 80 students, 80 undergrad, freshmen, with each freshman in class. So I think, certainly the lower division classes, if you're taking some of the general courses, those can be pretty big. So if you're taking your calculus courses, your chemistry, some of those courses are really big. I mean, hundreds of students in a class, and they may have multiple sessions. Those are courses that are taught university-wide. Once you start getting into biomedical engineering, then without a doubt, the courses get quite a bit smaller overall. And in particular, during their junior and senior year, that's when they start getting, a lot smaller. Part of it depends on the area that you choose. So again, I pointed out that, and it's pointed out in the worksheet, that there are different areas of biomedical engineering. So there's biomaterials, biomechanics, instrumentation, so on and so on. And depending on the area, some areas have more students than others. So biomaterials, for example, the courses are a little bit larger. I would say they probably hover in the range of about 40 students because that's usually our largest area. So we have most of our students there. The other areas like instrumentation, biomechanics, bioinformatics, they're usually quite a bit smaller. So I think the courses there probably would really be much more in the like 20, 20 students or so range overall. And then by the time you get to senior year, I think most of the courses are no more than 30 students for any of the disciplines, like 25 students at most. And courses will be generally smaller than that. So again, it's somewhat a little bit dependent on the area that you choose. Biomaterials is really the one area that's a little bit more crowded because we do have more students in there. By the time you get to your senior year, if you're not in biomaterials, I would say most of those courses are definitely below 25, probably more like 20 or less students. So it sort of varies quite a bit.
All right, thank you.
Yep, absolutely.
I'm just curious as to what your focus is and what you not do.
Sure.
Just
Yeah. So and I think this will give you sort of a sense of how broad biomedical engineering is. So actually, my focus is neuroscience. So I study the brain. I am actually I'm actually affiliated with biomedical engineering. I'm affiliated with electrical engineering, and I'm also affiliated with psychology department. And I actually do all my work in psychology department. I actually study hearing, so basically trying to figure out how different parts of the brain, how they listen to sounds, how they process the information coming in from a sound, and of course, there's many people who have hearing loss who have to either resort to things like hearing aids. Not sure if you're familiar with technologies like cochlear implants. So we work quite a bit in trying to understand how, first of all, trying to figure out what happens when you have hearing loss, and then second of all, how can you possibly remedy it? So if somebody does have hearing loss, how do you actually fix it? Are there ways that maybe you could come in, intervene? Of course, hearing aids help out, but they're nowhere near perfect. Same thing with cochlear implants. Those are devices that actually connect directly with your brain. They could actually help individuals who are completely deaf hear sounds, but it's nowhere as good as the normal functioning auditory system, the way we normally hear. So basically trying to understand how the brain works, how it solves problems of hearing, and then how to fix it, basically. So yeah, we actually have at the graduate level, we have a whole concentration on neural engineering, basically focusing on the brain. But at the undergrad level, it's a little bit too specialized. So it's not part of the undergrad program. But at the grad program, we do have that. We have a good number of faculty. Probably in the core, we probably have like 6, 7 faculty that focus on studying the brain as a whole.
so, do we have a focus on like prosthetics at all, or?
Yeah, the biomechanics area would focus on prosthetics. So they probably do a little bit of work related to that. In neuroengineering, there is a little bit of work related to neuroprosthetics. Now, like I said, neuroengineering is a graduate level curriculum, but there are courses that are offered at the graduate level. Some of them are offered concurrently as undergrad courses. So let's say that you're taking instrumentation, you would be able to take those courses. There's no reason why you can't, if it sort of fits partly within the realm of what you're studying. If you're doing instrumentation and, there's a course on prosthetic devices, which we have a couple, most of them related to neural prosthetics, prosthetics that interact with the brain. That would certainly be suitable. So you'd be able to take a course like that for sure.
But yeah, because the only reason I ask is because being able to connect your phantom limb to the prosthetic, I would think that's all normal pathway.
Yeah, so we have a couple of faculty that work with that kind of stuff directly. So I work a little bit with cochlear implants on the one hand. I don't have any courses that deal with prosthetic devices, but I do a little bit of work with that. There is Sabato Santinello. He studies, basically, he works quite a bit with more the clinical side of neuroprosthetics. He's working with quite a bit with deep brain stimulators that are used for treating Parkinson's disease. He's also looking at ways to, basically use implants in the brain to treat a whole host of other diseases, in the nervous system. So he's one person that he does that kind of work directly in the clinic with doctors, and he does have some courses on it. The other person is Martin Hahn. Martin Hahn, he doesn't really focus so much on the development of the computer programs and how to interface that with a computer device. What he actually does is he develops more the electrode devices. So anytime you have a neuroprosthetic like this, it sort of requires that you insert electrodes in the brain. Those electrodes are basically implanted. They go into the tissue. And the idea is that you want these devices to last a very long time. They're invasive. They go in the brain. You don't want them to deteriorate over time. You want them to be long lasting. And not only that, you want them to basically be able to pick up the brain activity very accurately over, the course of years without doing any harm to the individual. So he actually, basically does a lot of development of that. He has a handful of courses directly related to that as well. So yeah, so we don't, like I said, we don't have a program in that area. At the undergrad level, that's a little bit specialized, and that's why it's structured the way it is. But the courses are there, so there's a handful, like 3 or 4 courses related to those topics, and you would be able to take those as an undergrad for sure. So we do have undergrad students that will take that. That would all happen mostly in your senior year. So at the senior year, you get to take a handful of electives. It's usually in the range of 3 or 4 electives, and that's where you would be able to do that. Yeah, I should say maybe another thing that might be interesting. This is pretty new, so I'm not sure, what the timeline is for this. They are attempting to build a robotics program.
Really?
And yeah, they are. It's not in place yet, and I think one of the intended, type of curriculum within that is robotics applications to medicine, right? You could think about application of robotics where you could actually use it for surgical intervention. You could have robots that help you carry out basically surgery. But then, when you're talking about prosthetics, robots come into play too, because they are developing, for example, prosthetic devices that basically use robotic arms, and the idea is that you could actually take brain activity, control robotic arms, etc. So that those actually have been shown to be feasible. There's a number of studies that have shown that you could actually do that. You could actually take brain signals and use them to control a robotic arm, so that you have an individual who has no function, they're completely paralyzed, and they could take the robotic arm just by thinking about it. They could actually literally control it, pick up a cup of coffee, drink from it, etc.
How you would use your regular arm?
You can't. In that case, you can't. There are other ways that people, in that case, you have somebody who's completely paralyzed in a wheelchair, and they have an adjacent robotic arm that could actually help them do certain things. There are, people working without a doubt on ways of stimulating muscle. With the intention of, could you use your brain signals, bypass the damaged circuits in your spinal column or wherever it is, you literally bypass that, and then you could go in and electrically stimulate, let's say, muscle directly, with the hope that maybe you could regain function in your arms, your legs, so on and so on. So we don't really have anybody doing that kind of prosthetic here at UConn. There are some folks throughout the U.S. that are doing that, but that at this point, it seems like that's a little bit far away, because it partly requires working out these technologies on both ends, on the brain side and then on the muscle side. It gets to be extremely complicated. So, but nonetheless, I think at the undergrad level, we have a good number of courses related to that. This robotics program that they're trying to develop would probably also have some courses related to that too. That's all new. It's in the. I just heard about it a couple of weeks ago, so I didn't even know that was in the works So I have no idea what the timeline is for something like that, but they're talking about it for sure. Yeah.
So as an undergraduate, coming in as maybe a freshman, what classes would you be taking? Would it just be a bunch of prerequisites?
Yeah, at the freshman year, a lot of the courses that you would be taking would be more your basic requirement courses. Without a doubt, you want to make sure you have your math sequence, completed. So you would have the calculus sequence completed if you haven't taken that as an AP in high school. So Calc 1 and Calc 2. You would also take chemistry courses as well, maybe Physics 1 as well. I'm not sure if you take Physics 2 also, maybe Physics 1 and Physics 2, maybe both of those. You would also take, possibly some other requirements that you may have. You may have like English requirements and stuff like that. So I think a lot of that gets done early on. There is a engineering course that's taught by the School of Engineering that all the undergraduate students take on the first year. That basically, the course is a very general engineering course. It's just to give you sort of general exposure to the basic principles of how to think like an engineer and how to do engineering. I think part of the course is a little bit lab based, so some of it is instructional in class, some of it it's more hands on where you go in a lab and you start designing something and building something. Obviously not at the high level that you would in your senior year when you get to senior design, but the idea is that you get a little bit of hands on work and you get introduced into basic engineering.
If you've taken engineering courses in high school, would you be required to take those engineering courses again?
I think so. I think that course is only like a 1 credit course, so it's not like it's a huge number of credits. So I think you would still be required. I'm pretty sure. I don't know if there are any ways to bypass that and accept requirements from high school. There may or may not be. I don't know.
Right, because I've done PLTW courses. I don't know if you know what that is.
What are they called?
PLTW, Project Lead the Way courses.
I have no idea.
Anyway, those courses I take, and I don't know if they're all related to engineering, so I'd be curious if they would ever even consider.
I honestly don't know. I think for this, I will refer you to two people. There's next Tuesday, Dave Caputa, who runs the undergrad program. He may know more about that for sure.
Okay.
The other person would be, and when I say he runs the undergrad program, it's the Undergrad BME program. So he's sort of in charge of the daily operations of the Undergrad BME program. The other person, of course, would be the Dean of Undergraduate Studies for BME or for engineering, and that's Dan Berkey. So his office would for sure know. I think they would be the most likely ones to have, if they've dealt with this kind of stuff before, that kind of course that you're describing, and they would approve that as a, maybe as an alternative, approve that instead of taking this introductory course that I'm talking about. They would probably be the people that would do that overall. Yeah. Yeah. Let me. I'm gonna point you to just a page. Let me share my screen real quick. All right. So you guys see that?
Yes.
All right. So I'm just gonna go to the BME website. So if you go here, I think if you go to majors and minors, I believe that's where it is. Let's find out. Let's go here to 2019, 2020. All right, so depending on what discipline you choose, I think when you press these, it's going to give you a plan of study of what you take each year. So it outlines here sort of like what you're taking every year, depending on what area, what track you choose. So if you go back, let me just close this off. So let's say you decide to go with the systems imaging and instrumentation. I think in that case, that probably sounds more along the lines of what you might be interested in, Nathan. So if you were to do that, just so you could go through it and you get a sense of what's going on here. Freshman year, like I said, you're going to be taking things like chemistry. You're going to be taking math. So there's a Calc 1, Calc 2. This Foundations of Engineering course is a course that I'm referring to. I guess it's actually 3 credits right now. It used to be 1 credit. I know they were making changes a couple years back, so it looks like it's 3 credit course right now. I don't know, honestly, if that could be, if you could have a course from high school count for that. Maybe it's possible, maybe not. I'm not 100% sure. Look,
I don't think you would know this answer, but do you know any information about community college transfers coming into BME?
I don't. I'm afraid I don't know very much.
Okay.
Yeah. I think transfers can be accepted. There are, if you have transfers coming in from a community college in Connecticut, and maybe even outside Connecticut, and this is actually in general for like universities in general, especially for general courses like this, like calculus, etc. The university has a list of courses that sort of are equivalent to our courses. So a lot of that gets handled by the undergraduate studies office at the university. So they have sort of a direct list that says this course that is offered at this particular community college is equivalent to this course in at UConn, and if it is, they will allow you to transfer it. But if it's not listed, then they probably will not. So they have very specific requirements for that. So our department, I normally don't deal with that kind of stuff, so I don't know the exact answers to what courses would and what wouldn't. That would have to be verified by
contact for that kind of information?
What's that?
Would you know who to contact for that kind of information? Do you know?
I'm not sure if it would be. I think the dean of undergrad studies would probably be able to do that. I think that would be my starting point. And
Right.
if they can't do it, they would not know exactly who the person is for sure.
Okay.
I lost the page that I was looking at. Here it is. Yeah, so I think looking at these curriculum, the first couple of years are pretty much a lot of general courses. Even in year 2, as you can see here, sophomore year, you're still taking math. You're taking a good number of math. You're taking physics 1 and 2. You're taking some electrical engineering courses. Again, that sort of just gives you preparation so that you can do some of the more advanced work. And it's really not until your junior year that you start getting into some of the biomedical engineering courses. So you can see that right away. Junior year, you start with things like biomedical engineering measurements. You have the bioinstrumentation, so on and so on. Along with that, you're taking some electrical engineering courses too if you're in this particular track. Some of the other tracks don't have these requirements. I mean, if you go to look at, as an example, let's say we do Biomaterials and tissue engineering. The requirements are going to be totally different. The first 2 years are the same. So the first 2 years for every track are identical. It's really once you get to the junior year that everything splits off and everything changes. So as you can see right here, you'd be taking, biomedical engineering measurements. You take it, it looks like you take it in the other tracks, but now you're taking biomechanics, you're taking biomaterials, you're taking cell biology, so on and so on. So each track sort of at the junior year, they go their own way. And then you start taking more specialized courses that are relevant and, of importance to that particular track. That's sort of how the program works. So usually by the time you get to the junior year, you want to start, before you get to the junior year, you want to start really thinking about what is it that you want to specialize in. Because at that point, you have that split and everybody goes their own way. So you're sort of required to make a decision by then.
So for a master's program, what do usual BME undergrads go for as degrees? I understand the broad question, but
yeah, they go for they're quite varied. They basically cover, we have 5 areas at the graduate level. So students go into whatever, we get students in all the areas. Biomaterials is still our biggest. It probably sucks up like maybe a third of the biomedical engineerings, I would say, for biomaterials. And then the other tracks are a little bit smaller. In the undergrad track, the smallest track is computational biology and bioinformatics. For whatever reason, that tends to be the smallest track. It might be partly because computer science has a bioinformatics area, which is closely related. And that area actually sucks up a good number of students. So I think bioinformatics and computer science probably has like 40, 50 students or something like that. So that might be one of the reasons why that, in our department, it just turns out to be quite small. Now, in terms of what you're asking about the grad program, so master's. So we have sort of set up a 5-year master's program where you literally, you go through the undergrad and you could actually sort of continue on to pursue a master. It'll take you an extra year to do that. It usually requires about, I think it's somewhere around 24 credits extra that you have to take to obtain that master's. And the difference with the master's, and I'll show you again, I'll share my screen. So if you go back to the BME website, if I can find it, let me just type it out. It's probably easier. So instead of going to graduate, go to graduate and go to tracks and coursework here. So you could see the different tracks are a little bit different. And it's largely because of this. They're named a little bit different, but the neuroengineering, I think, is the one that really stands out as being different. So you also get the option of going into the neuroengineering overall. Within here, you could actually see some of the, it lets you see a lot of the grad courses that are available for each of the individual tracks. So these are actually courses that we have approved that if you, for example, let's say you're going to go into this area, into biomedical imaging and biosensors, these are all courses that would qualify for you to take in that track. That doesn't mean you're going to take all of them. You're going to just, for your electives, you're going to be selecting from those courses. And if you take from these courses, you're basically approved. But we do have this, that is a possibility. You could do a 5-year master's program. We have a good number of students that do that. Probably, like I said, we have about 80 students a year coming in as undergrad. And out of those, as they move on, probably about 30 a year continue on to get the master's. So a lot of the students, probably about a third, I would say, have been continuing on and getting a master's in the, using the 5-year opportunity for sure. So
beginning, popular hard for students in biomedical engineering to get careers afterward at a bachelor's degree, or?
Some do. We have it's sort of right at the, right at the senior year. From the statistics that we have, probably about 1/3 of the students are probably going on to, to go to a career. The other ones are, we get a number of students that are going into, probably about another third that are going into grad studies of sorts. Maybe even more than that, I would say, because 1/3 alone are going into the master's program. So they're already going into a master's program. And then we do get other students that go to other universities as well throughout the country, some even to PhD. And then the other students, we're not quite sure where they go exactly. So there are some students that are getting jobs right away. And, a good number of them turn out to go to grad school. More than a third, I would say, are probably ending up going to grad school right now. That's sort of the statistics that we have at the moment.
So finding a job isn't really an issue, I guess.
Well, it's, I wouldn't say it's not an issue. It's definitely possible. 1/3 of the students are doing that. The other ones, it's never clear to us why they are going to grad school. Is it because they can't get a job? Is that one possibility? I don't know. the answer to that. It's just because they feel like they want to get more out of their education, and continue. They feel like getting a grad degree will get them further on later on when they get a career. That might be a possibility too. I think it's a little bit of everything, right? Some may not have a job, and so they might say, "Well, let me go on into grad school." So it's not quite clear to us why that is, right, and why it breaks up the distribution that way. But there are opportunities. I mean, BME is relatively new. It really kicked on, and started becoming a major field back in 2000. It was around before that, but it was really in much more select programs, a handful of programs throughout the country. Right around 2000, there were a lot of programs and a lot of departments that opened up in biomedical engineering. And the field has been growing. Of course, I think you're very much aware that, there's a huge biomedical industry right now. There's tons of advances in medical technology, things like genomics and stuff like that. All of these, and the way science is progressing in general, science and medicine, technology is becoming more and more important. So I think it's pretty clear nowadays that biomedical engineering has become a major player, and it's become a much more, even though it's relatively new, you're talking about really grown dramatically in 20 years, it's become sort of a prominent engineering discipline for sure. And there are plenty of opportunities out there for sure. I mean, there's so much biotech. There's also, need in hospitals. Hospitals hire biomedical engineers. We do have what's called a clinical engineering program. So instead of doing, let's say, a master's in biomedical engineering, we are the only university in the country that offers a program in clinical engineering. And clinical engineering is sort of a specialized avenue for biomedical engineering. It really focuses more on the clinic itself, working in hospitals with medical technology. And so the program that we actually have is called the Clinical Engineering Internship. It's an internship we have about 10 hospitals throughout the country where students go out there. We get about 10 students a year. They go out to 10 hospitals and they literally take courses. Most of the courses are distance learning, so they're online so that they could be distributed to all the students. But the students actually work in the hospital at the same time doing an internship. And these are basically positions where, the idea is that you're actually working with medical technology, to be able to diagnose it, make sure that it's calibrated properly, make sure that it works properly, make sure that it meets doctors' needs and the medical needs, so on and so on. So that's sort of a special program that we actually have. We're the only ones in the country that actually has that overall. So we have some of our students actually go there too. Not too many. I mean, it's 10 students a year. Probably a handful, like 2 of our students will actually go and continue on to that. It's actually very selective, the program. So it's because you do get a whole internship. It's fully paid. So it's quite competitive overall.
Okay.
Logan, I don't know if you're still with us. Do you have any questions for me as well?
No, not at all. You answered a lot of them.
All right. That's always good.
Okay. So if we want to contact for community college transfers, I'd have to talk to the dean of undergraduate admissions.
Probably. I mean, I think they would be the ones who would know best. I mean, Dan Berkey's office, the dean of undergrad studies at School of Engineering, may also know too the details for that. But I think admissions would, without a doubt, they're the ones that do all the transfer, the admissions office and dean of admissions. So they would certainly know for sure. I think with all this, sometimes it's a question of knowing who knows the answer. But But secondly, it's a question of who's actually the most helpful. Sometimes the people who know the answers right away aren't necessarily the most helpful. So it's good to, I would try the dean of, go to admissions first, probably. It seems like they would know. Hopefully they would be able to help you out. And if that doesn't work out, Dan Berkey's office in the School of Engineering, the Dean of Undergraduate Studies for School of Engineering, they might be able to help out. I know that office is very helpful for sure. So they may be able to help you out with that.
Okay, thank you.
Yep. So which courses are you looking to transfer? What kind of courses?
Honestly, I'd probably try to get whatever courses I can to transfer. I would try to match whatever into biomedical engineering, try to get my first 2 years over with, and then I would transfer as a junior.
I see.
And then I would.
Have you thought about instead of doing if you're doing that, I know the transfers are probably going to be a lot less. I know if you have like 1 or 2 courses to transfer, they, if there's sort of courses that are allowed, they will do that. Coming in as a junior, I think the number of transfers would be a lot more difficult to get stuff transferred over. You might get a handful of courses. It's not that you won't get any, but will you get the majority of the courses transferred? I highly doubt it. Another option would be to go to one of the other branches and take some of the courses in the branches, the UConn branches throughout the state, like the Stanford branch, so on and so on. That might be a way for you to get some courses. And those courses would transfer over to, they're part of UConn. It's just that they're being taught elsewhere. They're not being taught here at the Storrs campus.
The only issue is I'm trying to do this in the most cost-effective way because I'm not really getting. I'm not saying I'm not getting a family help, but I'm not get loans or exactly. I don't want to come out of college, under debt.
I understand.
So
totally understand.
I'm going to do this most cost-effective.
Yeah, what I would suggest, without a doubt, if I were you, I would definitely talk to somebody about this first and try to get the details of what they allow and what they don't. Undergrad admissions, that might be a starting point. I'm not sure what office will be the most helpful for that, but I would definitely try to get some of those answers before you even go on this venture to do that. That way you could at least sort out what they're going to allow, what they're not. And if you know what they're going to allow, then maybe you'll take some of those courses, get that out of the way, and then move on. I think that's the approach that you want to take. You don't want to have any surprises at the end of the day where you take 2 years worth of courses, right? Or 2 full years, and then all of a sudden find that half of them are being transferred over and the other ones don't count for anything. Then it's just like you wasted money and you wasted time, and it's like, what's the point? So I would try to sort that out before you, decide on what to do. And then that way you could actually sort of plan to take the courses that you would be able to transfer over, really sort them out, plan it out, and then just go for those.
If I resided in Connecticut and I went to like part of UConn, that's still paying UConn tuition, correct?
I believe so. I believe the tuition is probably the same. I'm not 100% sure.
Right.
If you're full time, so if you're full time, I think the tuition, if you're taking it at the branch, I think the tuition is still the same.
Okay.
I think. Of course, if you're living at home, then you wouldn't have to pay the dorm fees and all that. If, on the other hand, you're just taking 1 or 2 courses, then I think you could pay on a per credit basis, but you wouldn't be considered full time if you did that. All right.
Okay.
So I think that some people might do that as well. But I don't, again, I don't know too much of these details because it's just not what I deal with on an everyday basis.
Right.
I'm not directly dealing with the admissions or anything like that.
COVID also doesn't help the situation. So
What again?
COVID doesn't help the situation.
COVID doesn't help anybody. It's hard. It's hurting it's just a horrible nightmare, right? For everybody. So, yeah.
The problem is
Yeah.
if I was thinking about trying to apply to UConn for 4 years. It's just I don't know when it comes to cost. I don't know how that's gonna come out. So we'll see.
Yeah, I think so. If you could, of course, live at home and commute, we do have a lot of students that do that. It all depends on how far you are from the campus, right? That's definitely a big saving for sure.
Does UConn not require freshmen and sophomores to live on
They
campus?
may, yeah, I'm not 100% sure what the exact policy is. I know in the past that's always been the case, but I know, I could even think a handful of years back where the dorms are so crowded that I believe they started allowing students to, live off campus because of that, undergrad students, because they were so crowded. So I don't know if that's still happening or not. I'm not sure exactly what the situation is right now. But I remember vividly, like 5, 6, 7, 8 years ago, that there was at least some period over which they were allowing some students to live off campus because there just wasn't enough, places for all the students to live. Yeah.
Oh.
So they may or may not allow it for freshmen. I'm not sure.
I don't think I have any other questions.
All right. Well, I guess you could always, ultimately you could email me, or the other person you can email is David Caputa. If you go to the website, I'll show you guys where that is. I think our emails are listed there somewhere. You go to about, probably. No.
Contact us.
Yep. So let's see who shows up. So that's my email right there. Lisa Ephram, she's our undergraduate academic advisor. She normally, I don't know if she deals with incoming students or not on a normal everyday basis. She does all the advising for our freshmen and sophomore. So I know she's extremely knowledgeable. So she knows everything about every single course students are allowed to take. She knows about transfers. She knows about everything. She may not deal with incoming students on a normal basis, but I know she would know a lot of the details. And I don't see Dave Caputa, but I'll point him out. If you go to faculty and staff and go to core faculty. So Dave is right here. So Dave, he's the undergraduate program director. So again, he does advising for some students as well at the undergrad level. And he knows the program, the undergrad program, and the requirements probably better than just about anybody. I mean, between Lisa, Ephram, and him, they know pretty much the whole program in and out. They know all the requirements. They know a lot about what can be transferred and stuff like that. They would know a lot of those details for sure. Yeah, so if you grab his email, Dave Caputa at UConn.edu, he would be very helpful.
Call them or email them for a reply.
Say that again?
Getting a reply from them, would it be easier to call them or email them?
Right now it's probably difficult to call them because nobody's working from the offices. Like literally the whole university, most faculty are working off site. So you may catch him in his office once in a while. He may go in once in a while, but a lot of time he's spending at home. So definitely email. And he's very actually good about responding. So he'll respond without a doubt. I'm certain he'll respond to you, no problem. If you have a question or anything like that. What's that?
Lisa Ephram.
Lisa Ephram. Yeah, that's Lisa.Ephram, I think. Let's see. Oh, no, it's actually Lisa E at engr.econ.edu. I would email Dave because Dave I would email him first because he is, he oversees the undergrad program. Lisa Ephram really more advises the undergrad students that are already in the program. She doesn't really deal with much that I know of with incoming students. So I think she would probably know your answers, but she's just not the person that deals with that normally. So I think for that reason, I would say probably go to, contact Dave. He would know a lot of the answers for sure.
Okay.
Yeah.
Thank you. All right.
All right, great. So I don't know if any other questions, Logan? Any other questions on your end?
Nope, I got none.
None. All right. Well, if that's it, I think it's about time. It's like coming at 8. I think this went 7 or 8, I believe. Is that correct? Let's see, Casey.
How long is this supposed to last?
I think it's supposed to be an hour. So I think it's supposed to be
8 o'clock?
so 8 p.m.
Okay.
I believe. So
Perfect timing.
anyway, well, good luck with everything, you guys, and yeah, don't hesitate to reach out if you have questions or anything like that. You can email me. You can email. If I don't know the answer, I'll just probably forward you to Dave Caputa. He's my next go-to person, and then he'll try to figure out, try to get you an answer one way or another.
Okay.
All right.
Thank you so much.
All right.
All right,
Brent,
thank you.
absolutely.
Have a good
Take
night.
care, you guys.
Have a
good
great
night.
day.
Yeah, you too. Bye-bye.